Hello friends, today I am going to reveal some true facts of new research in medical science. Wireless pacemaker for the brain could offer new treatment for neurological disorders. But first of all, I request you to please share and subscribe my channel for getting my informative true facts videos uninterrupted. Please note that subscription of my channel is free of cost. Now, new research in medical science. Wireless pacemaker for the brain could offer new treatment for neurological disorders. Device fine-tuned the treatment by stimulating and recording electric current in the brain at the same time. A new neurostimulator can listen to and stimulate electric current in the brain at the same time, potentially delivering fine-tuned treatments to patients with disease like epilepsy and Parkinson's. In a proposed device, two of the new chips would be embedded in the chassis located outside the head. Each chip could monitor electrical activity from 64 electrodes located into the brain while simultaneously delivering electrical stimulation to prevent unwanted seizures or tremors. A new neurostimulator developed by engineers at the University of California, Berkeley can listen to and stimulate electric current in the brain at the same time, potentially delivering fine-tuned treatment to patients with a disease like epilepsy and Parkinson's. The device named as WAND works like a pacemaker for the brain, monitoring the brain electrical activity and delivering electrical stimulation if it detects something amiss. This device can be extremely effective at preventing debilitating tremors or seizures in patients with a variety of neurological conditions. But the electrical signatures that precede a seizure or tremor can be extremely subtle, and the frequency and strength of electrical stimulation required to prevent them is equally touchy. It can take years of small adjustments by doctors before the devices provide optimal treatment. WAND, which stands for Wireless Artifact-Free Neuromodulation Device. WAND, Wireless Artifact-Free Neuromodulation Device, is both wireless and autonomous, meaning that once it needs to recognize the signs of tremor or seizure, it can adjust the stimulation parameter on its own to prevent the unwanted movements. And because it is closed loop, meaning it can stimulate and record simultaneously, it can adjust these parameters in real time. The process of finding the right therapy for a patient is extremely costly and can take years. Significantly, reductions in both cost and duration can potentially lead to the greatly improved outcomes and accessibility, said Ricky Muller, assistant professor of electrical engineering and computer science at Berkeley. We want to enable the device to figure out what is the best way to stimulate for a given patient to give the best outcomes. And you can only do that by listening and recording the neural signatures. WAND can record electrical activity over 128 channels, all from 128 points in the brain, compared to 8 channels in other closed-loop systems. To demonstrate the device, the team used WAND to recognize and delay a specific M movement to thesis max. The device is described in a study that appeared in a Natural Biomedical Engineering. Reapers in a pond. Simultaneously stimulating and recording electrical signals in the brain is much like trying to see small ripples in a pond while also splashing your feet. The electrical signals from the brain are overwhelmed by the large pulses of electricity delivered by the stimulation. Currently, deep brain stimulators either stop recording while delivering the electrical stimulation or record at a different part of the brain from where the stimulation is applied, essentially measuring the small ripples at a different point in the pond from the splashing. In order to deliver closed loop stimulation based therapies which is a big goal for people treating Parkinson's and epilepsy and a variety of neurological disorders. It is very important to both perform neural recording and stimulation simultaneously, which currently no single commercial device does, said former UC Berkeley postdoctoral associate Samantha Santa Cruz, who is now an assistant professor at the University of Texas in Austin. Researchers at Cortesa Center, led by Ricky Muller, designed by WAND custom integrated circuits that can record the full signal from both the subtle brain waves and the strong electrical pulses. The chip designed WAND to subtract the signal from the electrical pulses, resulting in a clean signal from the brain waves. Existing devices are tuned to record signals only from the smaller brain waves and are overwhelmed by the large stimulation pulses, making this type of signal reconstruction impossible. Because we can actually stimulate and record in the same brain region, we know exactly what is happening when we are providing a therapy, Muller says. In collaboration with the Lab of Electrical Engineering and the computer science professor John Rabe, the team built a platform device with wireless and closed loop computational capabilities that can be programmed for use in a variety of research and clinical applications. In experiments led by Santa Cruz while postdoctoral at UC Berkeley and by the electrical engineering and computer science professor Jose Camena, subjects are taught to use a joystick to move a cursor to a specific location. After a training period, the WAND device was capable of detecting the neural signatures that can, as the subjects prepared to perform the motion, and then deliver electrical stimulation that delayed the motion. While delaying reactions, time is something that has been demonstrated before. This is to our knowledge, the first time that it has been demonstrated in a closed loop system based on a neurological recording only, Muller said. In the future, we aim to incorporate learning into our closed loop platform to build intelligent devices that can figure out how to best treat you and remove the doctors from having to constantly intervene in the process, said Muller said. In my next video, I will reveal some true facts of other more important topics in science research. Thanks.